Okay guys, today is Unit 3, Day 7. It's kind of a continuation on what we did yesterday, some more word problems. The only two new things that I have for you guys on your notes today is we're going to be using standard form a little bit on our second page of notes, which is ax plus by equals c, and that's just when we have two different values for two different variables. And then we are also going to be solving for slope if it's not given to us, and that's when we're going to be using the change in y over the change in x. So that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's dive into our problems, and we will use all of the information from yesterday. So if you have questions, feel free to reference your notes from yesterday or the two new formulas that we have today. So number one says, in 1950, the population of the western United States was 23 million. In 1980, the population was 43 million. Write an equation that gives the population in terms of the year. Let x represent the number of years since 1950. So x is going to be our number of years since 1950. So remember, we're going to have to do subtraction if need be. So in 1950, that's like saying our year is 0. So that one we don't have to do any additional work on. But then looking at our 1980, that would be 1980 minus 1950. So that's going to give us 30. So this will be 30 represented. So our x is going to be our years, and our y is going to be our population. So if you look, we don't have a slope given to us. So we need to determine our slope based off of the two ordered pairs that we have. So our ordered pairs would read 0, 23, because in 1950 it was 23 million. And then our second ordered pair would read 30, 43 million. So we're going to use that slope form that we had up top, and we're going to do the change in y over the change in x. So I'm just going to label these here. This is going to be my y sub 2 and my x sub 2 and my y sub 1 and my x sub 1. So I'm going to do 43 minus 23 over 30 minus 0. So that's going to give me 20 over 30, which reduces down to 2/3. So my slope is 2/3 here. So let x represent the number of years since 1950. So if my x is 0, my y is 23, so that would be my y-intercept. So I have y equals 2/3 x plus 23. So there's my equation. So now it says, use the equation to predict the population of the western U.S. in the year 2015. So again, x represents 1950, so I'm going to subtract. And that's going to give me 65. So I'm going to do y equals 2/3 times 65, because my years are represented by my x, plus 23. So I'm going to put that in my calculator. And we're going to be looking at around 66.3 million. So we're going to just write our sentence. The population will be 66.3 million people in 2015. So let's look at number 2. Number 2 says, in 1986, a car dealer sold 450 new cars. She sold 600 new cars in 1992. Write an equation that gives the number of cars sold in terms of the year. Let x equal 0 correspond to 1980. So x is going to be my year, And if I'm corresponding to 1980, I need to go back and determine the information for my ordered pairs and figure out my year. So 1986, 86 minus 1980, that's going to be 6. And in 1992, that's going to be 12. So I'm going to write out my 2 points. So I have 6 as my x value of my year, and my y is 450. And then I'm going to look at my second sentence. 12 is my x, and 600 is my y. So here I need to figure out my slope. So I'm going to do the same thing I did above. So I'm going to label these y sub 2, y sub 1, x sub 2, x sub 1. So y sub 2, so 600 minus 450 over 12 minus 6. So that's going to end up being 150 over 6, which reduces down to 25. So my slope is 25, but I don't have a y-intercept given. So when my x is 0, then I get my y, but I don't have that value. So I need to put it into into point slope form, which is my y minus y sub 1 equals x times x minus x sub 1. So you can pick either point, and then you're going to pick your slope as well. So I'm going to do y minus, let's take our first ordered pair, minus 450. So y minus y sub 1 equals, my slope is 25 times x minus x sub 1, so that's 6. So I'm going to distribute that. So I have y minus 450 equals 25x minus 150. And then I'm going to add 450 to both sides. So I now have y equals 25x plus 300. So there's my equation there. So I just solved for my equation. And now B says, use my equation to determine the year in which the dealer sold 150 cars. So I'm going to rewrite y equals 25x plus 300. So I'm looking for the number of cars sold. So x is my year, y was my number of cars. So I sold 150 cars, so I'm going to put that in my y. So 150 equals 25x plus 300. So I'm going to subtract 300 from both sides. So I now have negative 150 equals 25x. So I'm going to divide both sides by 25, and I get x equals negative 6. So that's not my final answer, though, because remember, x is representing my year. So if x equals 0 corresponds to 1980, I want to take my 1980 and go back 6 years. So 6 years prior to 1980, that's negative 6 there, is going to be 1974. So in 1974, so 1980 minus 6. So in 1974, she sold 150 cars. There you go. All right, so let's flip to the second page now. So the second page is when we're going to be using our standard form. So this is our ax plus by equals c. So number 3 says, an interstate is being repaired by using two sizes of cement barriers. Some of these barriers are 5 feet long and some are 4 feet long. If the barriers total 5,280 feet, then write an equation that represents the different numbers of 5-foot barriers as x and 4-foot barriers as y. So all I'm going to do is write 5x plus 4y equals 5,280. So I took the information given to me. I have 5-foot barriers represented by my x, 4-foot barriers represented by my y, and then the total number of feet is 5,280. So there's my equation right there. So it says how many 4-foot barriers will be used if 1,000 5-foot barriers will be used. So I'm going to substitute 1,000 in for my x. And I'm going to solve for that. So I have 5,000 plus 4y equals 5,280. So I'm subtracting 5,000 from both sides. So I have 4y equals 280. And I divide those by 4, and y equals 70. So I would have 74 foot barriers. All right, number 4. Jeff is playing a video game with two sized targets. The larger target is worth 25 points, and the smaller target is worth 100 points. Write an equation that represents the situation if Jeff wants to score 1,000 points. So I'm going to take my values here, and I'm just going to take them in order. So I have 25, and I'm going to attach my x, plus 100 and attach my y equals 1,000. So my x is represented my large target, and my y is representing my small target. So there's my equation. So it says how many large targets must hit if he hits 4 small targets. So my small targets were represented by my y. So I'm going to substitute in 4 for my y. So 25x plus 100 times 4 equals 1,000. So I'm going to solve for my x here. So I'm going to subtract 400 from both sides. So I have 25x equals 600. So x equals 24. So he must hit 24 large targets. Jeff must hit 24 large targets. All right, and the last one here, number 5. In 1995, the number of students with cell phones was 600. In 2005, the number of students with cell phones had grown to 1,500. Let x represent the number of years since 1990. Write an equation that gives the number of cell phones, y, in terms of the year x. So we're going to take the information given to us right there. So x is our year, and y is our number of cell phones. So x represents the number of years since 1990. So we need to go back and look at the information given to us. So 1990 would be 0, so that means 1995 would be 5. Same thing with 2005. If 1990 is 0, 2005 is going to be 15. So we don't have a slope given to us, so we're going to write out our ordered pairs. So 5 is our x, and then the number of cell phones in that year was 600. Our next ordered pair would be 15, that's our x, and then the number of cell phones was 1,500. So we're going to use those two ordered pairs to determine our slope. So I'm going to do 1,500 minus 600 over 15 minus 5, and that's going to come out to be 90 after I do all the math. So my slope is 90, but I'm also missing my y-intercept, so I need to solve for that. So I'm going to do y minus y sub 1 equals m times x minus x sub 1. So I'm going to take my first equation, y minus 600 equals 90 times x minus 5. So I'll distribute that, 90x minus 450. So I'm going to add 600 to both sides. So I have y equals 90x plus 150. So there's my equation. Now it says use your equation to predict the number of cell phones in 2001. So remember, X represents the number of years since 1990. So we're using the equation to predict the number of cell phones in 2001. So that's going to be represented by 11. So we're going to do Y equals 90. And then our X is the year. So we're going to do 90 times 11 plus 150. And that total comes out to be 1,140 cell phones.